we are going to see the important problem, this single step design, right? So you need to follow the design procedure, then it is very easy, right? So here the first step is to calculate the normalized load impedance, right? So you need to calculate the normalized load impedance, right? As usual. So how do you calculate normalized load impedance? That is small zr equal to capital Zr divided by capital Zr. So what is capital Zr here? 40 plus J30 divided by 100. So what is the value? 0.4 plus 40 by 100 is 0.4 plus J30 by 100 is 0.3, right? So this is the first step, right? So what is the second step? This is the first step. Second step, you have to plot small Zr in switch chart as usual. In switch chart, right? So what is the third step? We have to draw a VSWR circle. For drawing VSWR circle, which one is the center, which one is the radius? 1, 0 is the center, and which one is the radius? Small zr is the radius. So these things we need to keep in mind, right? Then next part is, so we have to go for the fourth step, in which we have to draw 1 plus JB circle, right? So 1 plus JB circle or G equal to 1 circle, right? So this is the next step, okay? And the fifth step is, you have to find YR by extending ZR either upward or downward direction, right? Upward or downward direction, right? So these are the things we are going to do first. After this, we are going to map the, we are going to find out the values. That is, we are going to calculate distance between the step and length of the step. I will explain it to you how to find the distance. The seventh step, how to find the length of the step or location of the step. So these are the things we are going to find it out, right? So now I will do step by step. 0.4 plus 0.3. So this is 0.4. 0.4 plus G 0.3. Take this plus G 0.3. So both are intersecting at this point. So this is your small zr. Using this as the center, using 1, 0 as the center, using 1, 0 as the center, and zr is the radius. This is the radius. You have to draw a circle. This circle is nothing but this circle is nothing but the 1 plus JB circle. So this, right? So what is the name of the circle? This circle is VSWR circle, right? And after this, what you'll do? You'll try to trace this point, this value 1, no? This value 1. So that one you have to trace it. So this one value you have to trace it. And where it will end? Obviously, it will end at rightmost part of your switcher, like this. Similarly, you have to extend here also. So definitely It will end at this one, right? Now I'm going to consider my Smith chart as Y chart since we are going to design a shunt stub, not series stub. Yet since we are going to design a shunt stub, we are going to consider the chart as Y chart. So that's why this circle, name of this circle is 1 plus JB circle or G equal to 1 circle or unit circle. The different names will be calling by different people, right? So now after this what we'll do? Now from Vijata towards center, draw a straight line like this. Okay, right? So now at some point this straight line is intersecting with VSWR circle. This point is known as OR. Okay, this point is known as OR. Okay, so now we have to locate 2 points. That is VSWR circle and 1 plus JV circle is intersecting at 2 points. One is Y1, the one which is intersecting with VSW 1 plus JV circle Y1, the lower one is Y2. Okay, so always this is Y1 and this is Y2. Okay, so what next step is to extend this from the center towards Y1, right? Similarly, here also from center towards Y2, draw a straight line. Okay, now we are going to find out the distance, right? The distance is very easy, right? So you have to mark whatever I am going to do is the same thing you should done in your exam, right? Between yr and y2, right? Between and y2, that is nothing but the distance d2, right? So you have to look at wavelength towards a generator scale and you can find it here. The value is 0.3, 0.32, right? 0.32, not 0.32. Whatever the value is there, you have to write it like 0.30, right? 30. Next value is 0.330. Here the two values big again of 0.30, so 0.302 lambda, right? Here what is the value? 0.32 lambda, right? So what is the distance between 0.302 lambda and 0.302 lambda? Obviously the value is what? 0.018 lambda, right? So this is what the distance between this and this, right? Next we are going to find the one more distance. That distance is very easy, right? So for this what you'll do? You'll be putting like a you have to put e, you have to draw like this, you know. So from here OER, right? Always from OER, so you have to go like this. From OER you have to go like this. From OER you have to go like this. See, I'm drawing freehand. Okay, please you use an compass, right? So this is nothing but D1, right? So this you have to write like D1. So now tell me where the value D1 is located, right? So already we know that this is 0 lambda and this is 0.25 lambda, and again if you are coming here this is 0.5 lambda. So after 0.5 this is 0.51, 52, 53, right? That we know, right? Wavelength over generator. So now you have to look at whatever the value is there, just add. Now we have 0.18. So this 0.18 lambda has to be added with which value? 0.5 lambda. Why? Because we have already traveled, right? So 0.68 lambda. From 0.68 lambda, which value should be subtracted? 0.302 lambda, right? So 0.68 minus 0.302 lambda. What is the value? That is nothing but 0.68 lambda minus 0.302. That is what the value, right? 0.53 is 278. So D21 equal to 0.278 lambda, right? Not 278, I think. 2878. Sorry. So 0.68 lambda minus 0.302 lambda, right? So the value is around 0.378 lambda, not 278, 0.378 lambda, right? So these were the distance d1. Okay, so in this way you will have to find out the distance, right? So I hope you are clear with it, right? So you have to draw a VSWR circle, 1 plus JB circle, that will intersect at 2 point, namely y1 and y2, right? From yr to y1, the distance is d1. From yr to y2, the distance is d2. Always move clockwise direction for to find the distance, right? Next, we are going to find out the length, right? For finding the length, the concept is very easy, right? For finding the length, so here you need to trace what is the value of y1, right? You need to trace what is the value of y1, right? For example, the value of y1 is something like 1 plus j. In this particular problem, 1 plus j 1.5, right? Is here 1 plus j 1.5, right? So 1 plus j 1.5 means, see, why we are going for this kind of stub network? Why we are going for this kind of stub network? Yes, for achieving what? For achieving, yes, for achieving which one? Matching purpose only we are going for this kind of stub network, right? So what is the value of y1? Y1, the value is 1 plus j 1.5. The meaning of stub is nothing but to make yr equal to y naught, right? In order to make 1 plus j 1.5 to be 1, which value should be added, right? Which value should be added? Minus j 1.5 should be added to make the value to be 1. Similarly, here the y2 value is 1 minus j 1.5. So which value should be added to make the value to be plus 1? Plus j 1.5 should be added to make it this to be 1, right? So the amount of susceptance, extra susceptance is to be added is nothing but the extra length of the stub or location of the stub, right? So we have to mark plus j 1.5 and minus j 1.5 to find length, right? Right? So where the value plus j 1.5. For matching this y1, we need to have minus j 1.5. Minus j 1.5 is here. So minus j 1.5 is here. So this point. So this one, right? So this one minus j 1.5, j 1.5, right? This is plus j 1.5, right? So now that is nothing but trace of y1. That will denote the location of the first step, location L1, and this is location L2. That is, trace of y1 is L1, trace of y2 is L1, and trace of y1 is L2, right? So now next you have to look at whether the stub is open circuit stub or short circuit stub. Here open or short. Open means you have to start from here. Open means you have to start from here. Short means you have to start from here. Since we are considering this stub as what? Short circuit stub. Since we are going to consider this as a Y chart. So this is open and this is short. Right. Right. So finding the length, what you have to do? Already we marked the value, right? So from here to here, we have to measure from here to here. This is L1. Like that, you have to mark. Unless otherwise, if you are not marking the value, we won't put the mark L1, right? Similarly, first mark it, then we will find the value, right? First mark it from where to where we are finding. Okay, then only you'll be getting good marks, right? So this is L1, right? You can refer my material wherein I will mark all the values. Okay, so kindly go through my material. So now from this to where up to this, because this is L2, right? So now we have to find out the value of L1 and L2, right? So what is L1? So L1 is actually the short circuit it is located as 0.25 lambda. This L1, what about this plus minus j 1.5 is located at where? 0.34 lambda. 0.34 minus 0.25. What is the value? 0.34 minus 0.25. The value is what? That is what? 0.34 minus 0.25. That is 0.09 lambda. Right? So that is what the length of the first step. Similarly, what about this? This is 0.25. This is zero point 0.5 already. And what about this L2? L2 location is, don't put L2 location as 0.156 lambda. Why? Yes. Already we travel zero point 0.5 lambda. So again you have to add zero point 0.5 lambda. Then will it become 0.656 lambda. This 0.656 lambda should be subtracted by 0.25 lambda. I hope you'll be getting what I'm saying, right? So this 0.656 lambda should be subtracted by 0.25 lambda. Don't put the value in minus, right? So this was so 0.406 lambda will be the L2, right? So like that you have to find out the length and of the stub. Okay. So thank you guys.